Git attack at int I const, and then we need a non-const version because life is fun, and maybe we want to be able to modify that attack. Maybe, I'm not sure. Oops. Some of you guys were having issues with generating the correct type, syntax for declaring your functions. You can see if you're using C-line like I am, you can just position your cursor on top of the declared member and then press Alt-Enter, at least on Windows. I don't know what it is on Mac, and then it will give you the option to generate the function, and it will correctly type everything out for you. Command N. Thanks. This just would be return attacks.at_I. And this one would also be the exact same thing. Great. And then we can now return git attacking Pokemon.get attacks attack at I. Oh, maybe we don't want I, we want something like this. Yeah, 1 second. Yeah, we need the I++ and then move num and then. That's a question? Okay, so now we have that attack. And I wonder if it'll build now. Let me just see if I forgot anything. Oh, okay. Undefined reference to print winner. I guess we did leave off one function. So what should we say? Maybe like std : cout, Oh, this one doesn't have a Git name on it. And we'll try once more again to build. Hey, ran. And in main, did we actually have them fight? Okay. So let's see where we're broken at, because odds are we're going to segfault somewhere. Oh, maybe we should have a little bit more printing. We might have something like I wasn't sure who was actually doing stuff. We're going to throw in their names. Okay. Oak. Okay. So what do you want Professor Oak to use? Okay, he'll use quick attack, right? But, you know, maybe we want some more information like, hey, you got hurt for some amount of damage. So that's not there. So we should go add that in because we're not sure like who has how much health left. Right? Because if we just like keep putting in like attacks and like somebody won, okay, great. I mean, it's like a little bit ambiguous here. Like I probably should have won after doing 2 of those attacks. We can't see anybody's HP, so we probably want to start displaying that now at the beginning of each round. So maybe over here in battle. So we might say for const auto reference Pokemon and then but anyway, right, there's probably a little bit more that we could improve about things printing out. So Oak has 150, probably should say HP left, blah, blah, blah. Chen has 200. Okay, so Oak maybe uses Bolt Tackle, and Bolt Tackle, you know, left him with some amount of HP, and then, you know, Chen does some attack, and it left Oak with some HP, so his health went down. Right, and then Oak does a Bolt Tackle, then, you know, Chen has some HP, then Chen's like, oh, hit you with the midterm. He lost a lot of health. But maybe like Oak strikes back with his Bolt Tackle. Oh, he's left with 2 health, and then, you know, finish him off the second midterm. But like one thing we see here is that even though Chen should have actually won, right, it said Oak won the battle, so there's a little bug in terms of printing for who won because of how switching works. So, you know, for printing the winner, maybe it's not get attacking Pokemon, maybe it's like get. We have get defending Pokemon? Yeah. Wasn't. Wait. I don't know why it's not popping up. Oh, because we don't have a const version. Const. Okay, come on. Why aren't you letting me generate my... Okay, well... Okay, and so here, this guy would now need to be like C begin, C end, because we're gonna make sure that we get the const reference and then return it. Great. So there's a lot more stuff we could do to make this better, look nicer, but hopefully that gives you a decent idea of what you would do if you wanted to implement this game. Do you guys have any questions about how we broke this problem down into classes, how we're like making sure to try to provide some encapsulation and abstraction by not making all of our members public, right? In your homework, you should not just be making everything public just because it makes your life easier. You should be deciding like what things should be private, what things shouldn't people be able to use, or what things should people have like a controlled access to, right? Make those members private and then give them controlled ways of accessing those values through getters and setters to be able to change them, right? Just don't make everything public. Or don't make everybody your friend, because not everybody's trustworthy in the world, right? They might do bad things to your private parts. So you gotta watch out, right? Not everybody's trustworthy. So just because like something might be causing you like issues right now and you might be like struggling like comprehending how to use it, that's kind of okay. You want to be practicing with it now instead of just ignoring it and hopefully it goes away, because it's not gonna go away. It's gonna show up someday, and if you don't practice now, you're gonna suck at it later. And the problem will be harder. Any questions? Yeah. So the question is, why do we need the const functions? The const versions of the functions is so that we can access or call those members in const contexts. So for example, over here, right, I declared print winner as being const, right? Because we wouldn't think that, you know, printing out who the winner is should change anything about us, right? Shouldn't change anything about the battle telling us who won. Agreed? Right? But before, when we had get defending Pokemon, we didn't mark this function as const, right? Because we didn't mark the function as const, right? We said that we might change the thing, right? Because it's not marked const, we might change. And so our const functions aren't allowed to call our non-const members because they might change ourselves, and we promised not to change ourselves when we were called. Does that make sense? That's why we had to provide this const function over here so that we could call it back over here in print winner. Any other questions? Okay, then let's talk about our next topic. We only have 2 topics left to cover in the quarter, surprisingly. We have inheritance, which is a big one, and we have exceptions, which is a small one. Did we? Oh, 1 second. So if you have questions about this topic as we're going through this, please make sure to stop me and ask, because this is like one of the cruxes of object-oriented programming. And if you don't understand this topic well enough, you won't be able to use one of the most powerful features that's offered by this concept. So in object-oriented programming, there are 2 major relationships. There's a has-a relationship, and it's an it's-a relationship. Up until this point, we've been focusing on has-a relationships, right? Like a node has a next, a node has a prep, a node has a value. A Pokemon has a name, has a type, right? Has health, has attacks, right? Attacks have names. Attacks have amount of damage they do, right? Windows, right, have a cursor where they're at. Windows have a size. A board has a size, right? A board has pieces on it, right? Everything is like has a relationship. Has a relationships are things are made up of other things, and they're super common. These are expressed in your programming by your member variables, right? A linked list has a tail, has a head. It's made up of nodes. It has these things. The other type of relationship is inheritance, and it's like if a class is a thing, it should inherit. And you generally go from more specific to less specific, right? A good example of this might be vehicles, right? A car is a vehicle. A boat is a vehicle. A plane is a vehicle. These are all vehicles, right? Or you might have that like a mammal. A mammal is an animal. A cat is a mammal, right? These are all relationships of is a, right? You might have types of like Wi-Fi, like you might have like network connections. You might have a Wi-Fi connection is a connection. An Ethernet connection is a connection. A point-to-point connection is a connection. A Bluetooth connection is a connection, right? These are all is a relationships, but one is more specific than the other. With me so far? So again, inheritance is going to encapsulate the idea that some things are in life, or at least something else, but a little bit different or a little bit more than the original. As an example, if your parents die, you're going to inherit their wealth. Hopefully, right? Not their, you get the debts too, but. So you have their wealth, right? Their original values plus your own wealth, something more, right? Again, like mammals are animals, but they have something more, right? They have like bones. Whereas like insects are animals, but insects don't have bones, right? It's something plus something more. Or again, you might inherit some traits from your parents, right? Like their looks, taste, genetic predispositions, but you also are going to develop your own unique tastes, styles, interests, etc. that are different from your parents, right? You might learn from your parents how to behave in a certain way in a certain social interaction, right? But you might also do something different than they would, right? For example, you go to the like Burger King, and for some reason they refuse to make it your way, right? They won't put cheese on your double cheeseburger, extra cheese, right? Like you might handle some situation different than your parents. So this is what the inheritance is about. So we can do the same thing with inheritance in code. This is going to save us a lot of rewriting of code for objects that are similar, that have the same data members, right? That have the same methods, right? But it also is going to allow for different behavior in different situations and how you're going to react to some stimulus or some function call. This is what the syntax looks like. So you say your class, whatever class you want to create, colon, an access level, public, protected, or private, and then the parent class that you want to inherit from. This isn't saying that the child class isn't going to inherit from the parent class and the given level. When you inherit from your parent, you get all of their members, all of their methods. Another name for the parent class is another name for the parent and child classes is the base class, which would be the parent, and the derived class is the child. And like access levels that you're going to specify, like is 99.99% of the time going to be public. It's almost never anything else. And it's really hard to find situations where it isn't going to be public. For example, we might have something like a line, right, which represents this idea. And lines have a slope, and lines have a y-intercept, right, where they cross it. Then you might have a line segment, right? Is a line segment a line? Yeah, but it's a little bit special in that it has a length, right? It has everything that the parent has. It's still going to have a slope. It's still going to have a y-intercept, but it's going to have a length. Or it might also have like a starting point and an ending point, but it still has all the same properties that the parent has. So it's a good example, but you might want to consider generalizing the problem a little bit more. Instead of having your method be walk, maybe your method is move. Move from point A to point B, right? Or again, if we go back to our vehicle example, we want our vehicle to be able to move from point A to point B. But the way that boats move, and the way that cars move, and the way that trains move, and the way that planes move are all different from each other. In general, though, it's generally not going to be the situation where you don't have stuff that you have, your parent has something that you don't want, like the walk method that you mentioned. I don't think there's a way of saying that I don't inherit it, and I don't think there's a way of changing the access level from it to be like private, because that would be like the ideal, is you make that member private so you couldn't call it from outside the class, which I think you're getting to. But I know you can take all of your parents' methods and make them private inside yourself, but I don't know how you can just say a singular method. Like you want to just drop this one. What you could do though is you could like override your parents' method for walk to throw an exception if somebody called it on the snake. Does that make sense? So you couldn't check for it at compile time, which would be ideal, but at runtime, if somebody tries running that function, you can make an error happen. I think there might also be a way that we could get the compiler to complain using some template metaprogramming maybe. But I'm not sure. Does that answer your question though? Any other questions? Yeah. No, it's gonna be public up here, and we'll discuss the access levels and what they mean in a little bit. But basically, when you specify the access level, it's saying like, I want to have everybody have at least this protection level. And since public is the loosest protection level, basically the protection levels of your parents' methods don't change. So what's public in your parent stays public. What's private in your parent stays private. What's in your protected in your parent stays protected. If you specify a higher access level, it's going to say that everything I inherit from my parent, the protection level needs to be upgraded to at least that. So if I said protected, everything that was public now becomes protected inside me. Or if I said private, everything that was like everything inside my parents' code now becomes private inside me, and I can't access it. So what do you actually get when you inherit from your parent? So you get everything except for its private members. Is a little bit of an iffy one to talk about there. You sort of kind of do, but you sort of kind of don't. You don't get the constructors and destructors. You have to write your own constructors and destructors. You don't get your assignment operator, and you don't inherit their friends. So yeah, you would inherit all the other operators, yes, but you wouldn't inherit the assignment operator. So again, here are your protection levels. So public, you, your child, and everybody else can access that thing. Protected, you and any class derived from you can access that thing. Private, only you can access it. That's why we're saying that you don't inherit those members, because inside the child, I can't access my parents' private parts, right? Those are still off limits. So inside of my child, I cannot access Z because it's being declared as private. But I could access Y and X. Y because it's protected and I'm its child, and X because it's public, accessible to everybody. So again, you can declare that the inherited level is a little bit more strict when you inherit it. So it's members that you inherit from your parent will again at least be that restrictive inside you. Again, it's very extremely uncommon for this protection level to be anything but public. So for all the code we're going to do in this class, it's going to be a public inheritance. So don't worry about that. So for example, here's how everything changes. So here's your derived class, your child class, and here's what you're going to get inside the child. So here, everything that was public inside the parent becomes public. Everything that's protected inside the parent is protected inside you. If you inherit at the protected level, everything that's public now becomes protected, and protected stays protected. And then if you inherit at the private level, everything from your parent becomes private, and you can't access it directly inside yourself anymore. It's kind of weird, so it very rarely happens. So there are two types of reasons why you might inherit for something. The first is data inheritance. You want all the members of that base class, but you need to add in some more things, right? You know, again, I guess like the example might be like, I'm a vehicle and a car is a vehicle, but the car needs to add things like an engine and wheels and a drive shaft and a name or whatever else it needs to, right? The parent, a plane needs to inherit from its parent, the vehicle, but it needs to add things like a wings and passenger capacity or fuel capacity. Right? It needs to add different things that its parents didn't have. But things that would be common to all vehicles, like maybe their capacity, should probably be placed into the parent, right? Or fuel capacity probably should all be placed into the parent. And like fuel, like miles, like fuel usage should also probably be in the parent as well. Everything that's common to them should be in the parent, and everything that's distinctive to that one particular subclass should be inside the child. The other thing that you might want to do is interface inheritance. You want the same methods as the parent class, but you might want to change how those methods behave inside yourself. A lot of time when you inherit, you might be doing it for both reasons. The interface inheritance can be really, really powerful when you're doing large programming. And what it's called is you program to interfaces. So you create, well, we'll talk about that in a second, but you create a purely abstract class, a class that you can't implement, that just defines, here's all the methods I'm going to provide. And then you provide some concrete implementation of that class to be able to do those things. This makes changing your API, or at least your internals, not your API, your internal implementation a lot easier than if you just provide the concrete class. Yeah. So C++ doesn't have anything that's directly called an interface, but what you can do is you could create a abstract class who only has methods and no members, and then it behaves like an interface in Java. So again, let's say you want to be able to modify one of your parents' members' methods behavior. So what you do is in your parent, anything that you want to be able to change, the child to be able to change, you declare as being virtual, right? Which you've seen that with the destructors, right? The child probably needs to destroy itself in a little bit different way than the parent does because it's adding new things in. That's why you always want to make sure your destructors are virtual. Then inside the child class, you just declare a function with that exact same signature, and then you write your code that you want to have called when your function gets run. And you will then call the child's method as opposed to the parent's method. When you override your parent's methods, you should put the keywords override at the end. So in this example over here on the right, we declared greet as being virtual, which means our child is able to override its behavior. But because leave has not been declared virtual, our child cannot change how that behaves. Right? We've not given them that permission. So here is our child class. So we declare him as being inheriting from the parent with public inheritance. Inside our public section, we have virtual void greet. Again, override. It's exactly the same as greet was back here, except you've seen this new addition of the override keyword. And then we see out something different. So now if we have an instance of the child class and we call the child's greet, it's going to say buenos dias. But if we have an instance of the parent class and we say greet, it's going to print out hello, whatever we said. But we can't override the parent method. When you're attempting to override your parent's behavior, you really want to make sure that you put that override keyword there, because that will cause the compiler to double check that that function really is overridable. And if it's not, it will complain at you and say you can't do that, which is really good to catch right now, because sometimes you might accidentally make the mistake of like mistyping the name of the function, right? Maybe you have something like tear down, right? And it's capital T-E-A-R, capital D-O-W-N. But you put the D as being lowercase in your version, but you don't mark it as override. You just created a new function. You didn't change your parent's behavior. But if you put the override keyword at the end, it's going to say, hey, your parent doesn't have a member called tear little case down. And then it would say, hey, I'm not going to compile. And then you're like, oh, oops, mistake. Yeah. Correct. What virtual does is it allows your child to override the behavior of that function. Mm-hmm. Mm-hmm. So yeah, virtual only has this one meaning. It just means the child is able to override the behavior of this function. If you don't override your parent's method, you use your parent's code instead. So again, if we try to do this, we do get an error here because it wasn't marked virtual. And we can also add in more methods as well, right? We can add in as many new things as we want. And now I have a question for you. What's the difference between overriding a method and overloading a method? Yeah, exactly. So an overload of a function, right, is a function basically has the same name, but it has different parameters or different signature, right? An override is changing how my parent's method behaves inside me. So they're very similar in terms of names, but they're quite different in what they do. So the compiler will know, based on the type of the function, which of these versions of the function to call. So if we have a parent P and a child C, and we do p.greet, it's going to call the hello function. If we do c.greet, it's going to do buenos dias. p.leave, goodbye. c.leave, again, we didn't override it, so we use our parent's code, and we just say goodbye. Any questions so far? Yeah. So the question is, in the child class, can we overload that function? Or so you want basically us to do void leave, no override here? No, it's ambiguous. No. I don't believe so. We could try it out, but I'm fairly sure it's ambiguous as to which one to call. But we actually might be able to do it, but then you're going to get that, like, not the behavior you're expecting when you start relying on polymorphism. I would say don't, but you might be able to. We'll try it out later. See if that works. Just remind me to do it and see what happens. Any other questions? Yeah. Okay, so the question is, my parent does something really, really complicated. I want to do the exact same thing plus a little bit more. Now, the question that I have for you is, where does that little bit more that you want to do lie at? Is it before you do what your parent would do, after what your parent would do, or in the middle? In the middle, you're screwed and have to rewrite it. If it's before or after, it's fine. What you can do is you can do your new stuff in the before or after, and then you can call your parent's function. If you override a function, it's still possible to call your parent's function. To call your parent's function, name of parent class, : parent member method that you want to call. And then it'll go call that one. But again, sometimes it's like I need to do that little thing in the middle, and then you're like, well, I'm screwed. Yeah.
So, function error.
Oh, okay, so let me understand this. So the parent class provides some method called foo, right?
Yeah.
It's marked virtual. In the child class, you override that function, right? And so your question, and so you have it do whatever it is that you want it to do. So now whenever I do child.foo, it will call the child's foo and do what I want, right? But is your so in the child's foo, you could call your parent's foo if you wanted to, right? You could do that and then do the more if you wanted to. But like if your question is like, can the child like go rewrite the parent's code? No, right? Because one parent can have more than one child, right? So you wouldn't want, you wouldn't want a child to be able to modify the parent's code because there might be other children that rely on that. But you could certainly provide your own you could certainly override the behavior of that function and make it look like inside any instance of that child class that is doing exactly what you want and none of the parent's code runs. Okay, so the question, just to make sure I got it, is your parent has a static member, right? Then you have you have a child class that inherits from the parent. So is your question, does the child get that parent's static member? So let's get a little reminder. When you declare a variable as being static inside of a class, what does it mean? It means there's only one instance of that variable, right? Everywhere in the entire program, right? Whereas with most member variables, every instance has their own copy of that variable. Since there's only one, right? If we go and we change it in the parent, it's changed. If we go and we change it in the child, it's changed because there's just that one copy of that variable. You don't really inherit the static members, right? There's just like one variable, period. Right? So you can think about static members in some ways. Are there just global variables inside that class's namespace? If that makes any sense at all. Right? There's only one instance of that copy, and so the children can't really inherit it to be able to have another copy of it, right? There's just one copy of that variable, period. So there won't be a child copy of it and a parent copy. There's just one copy of it in the parent. You can inherit from multiple classes, and we'll talk about that in a little bit. Anything else? So again, we just talked about this. If you want to call your parent's method, parent class : parent method, calls it. This also is what allows us to disambiguate between our parents if they both happen to have, if we have multiple parents that we inherited from, and they both happen to have the same function, how do we disambiguate which one do we want to call? Right? You say their name. Parent 1 or parent 2's function name to get that to work. Yeah. So the question is, if you inherit from multiple classes and they both provide a function with the exact same name, and you call it, or they happen to have the exact same name, is that a problem? No. It's just that now when you need to call that function, you have to disambiguate between which one do you want to call. Do you want to call parent 1's method or parent 2's method? So you have to do parent 1 : method name or parent 2 : method name. So again, every class is going to need a constructor, and what you can do is inside of your class, the child class, you can call your parent's constructor to initialize the parent parts. And then the child part can be responsible for initializing the remaining portion of itself, the new stuff. If you choose not to explicitly call any of your parent's constructors, the default no argument constructor will be called. So again, here's my parent, right? It has an X and a Y, and X gets set to X, Y gets set to Y. Do whatever other code you need for initialization. Now here in my child, he has a constructor that's X, Y, Z, and A. So I can call my parent with X and Y to initialize the parent parts, and then Z and A to be initialized to whatever they're supposed to be. Does that make sense? Any questions here? Okay, polymorphism is when things get kind of cool. So what you can have is a parent pointer can point to anything of parent type, or it can point to any of its children as well. If you have a parent pointer and it's pointing to a child type, you're only able to access the parent methods through that child. Does that make sense? So like if the parent has a function called foo and the child has a function called bar, if you have a parent pointer to the child, you can only access foo, you can't access bar. Because only parents have foo. Children, their new thing is bar. What really kind of like happens when you inherit is you kind of like stick all your stuff at the end and they're stacked on top of each other. So here's my parent, I now add the child stuff underneath. So the parent pointer is allowed to go into any of the parent parts, not to any of the child parts. Down here. Yeah. So the question is like, can you cast a parent pointer to a child object to a child pointer?
A child object.
No, you can't cast a child type to a parent type, nor a parent type to a child type, unless there are like casting operators provided inside of the child to say how it gets converted into a parent, or inside of a parent how it accepts a child to be converted into it. So you could make it happen, but you probably don't, and there's some really weird edge cases where if you have a function that says like it returns a parent object, but inside you return a child, right? What's going to happen is, because you said that you only return a parent, the child part gets lopped off. And that can cause really weird behavior when it gets passed back up because you're expecting the child parts to still be there. Well, we can cast pointers. I can't cast the type itself, right? So I can cast like a parent pointer to a child pointer or a child pointer to a parent pointer, but I can't cast parents to children or children to parents. It depends on whether that pointer, so we're going to get to this in a little bit, but child pointers are always convertible to parent pointers. Parent pointers are sometimes convertible to child pointers if they actually point to children. Right? If you do the dynamic cast to cast a parent pointer to a child, and that actually points to a child, you'll get the cast will succeed and you'll get a pointer to it. If you try to cast a parent pointer to a child pointer and you're not actually pointing at a child, it will give you back null pointer. That's how you can check whether what you're actually pointing to. There's also issues of casting references as well, because the polymorphism also behaves the same way with references, but the casting would throw an exception if it wasn't pointing to the correct type. Yeah? The question is, if you had a vector of parents, could you add a child to it? No. But if you had a vector of parent pointers, yes. See you guys on Monday.
Discussion, someone said we cannot use Valgrind using the Linux subsystem on Windows.
Correct.
But I just use it.
Well, that's interesting because everything I've always read about Valgrind, it says it only works on Linux, period,
But
the end.
I think the subsystem actually is like an instance of Linux. So everything I've tried on it has worked for me.
Cool.
And I just wanted to tell you because I remember you said you had to like copy it to a Unix system.
Yeah. That's for everything I read about the Linux documentation said it only worked on, or Valgrind documentation said it only worked on Linux.
So I'm guessing that this is an actual like Linux.
Maybe, or we've had some people that tried to use Valgrind on Mac, and it kind of worked, but was a little unstable and didn't work perfectly. So just say be careful.
That's right.